So in part 2, we're going to look at the graphs of 6 different relations. The first thing we're going to ask is whether or not it's a function. If it is a function, then they're asking us to find the domain, the range, the intercepts, and also talk about symmetries. Let's use our vertical line test and determine which of these are functions. So we can do that fairly quickly. When we take a look at the very first one, we'll notice that our vertical line intersects this twice. So this is not a function, so no. Not a function. And because it's not a function, we don't have to do anything else with it according to the online homework. Please note that you could find domain and range. They're not limited to just functions. You can find the domain and range. You can also find the intercepts. You could also talk about symmetry, but the textbook is not asking us to. What about the next one? Is that a function? Well, anytime I stop my vertical line, it's only touching that graph one time. So that's the function. So this one will definitely have to come back and do. Okay, what about C? Same thing. So even though this looks like it's getting straight up and down, it's actually, if you could zoom in, getting closer and closer to the axis, but it's still moving over to the left, is never becoming truly vertical. So this one's also a function. What about D? So again, here's my vertical line, moving it all along the length. It only intersects one time, so that's a function. We'll come back and do it. What about E though? E, is that a function? Well, no. There are lots of places where it's going to intersect it, so this is not a function. Not a function. So we're not going to find its domain and range, although you could. And then finally F, sure enough, it's a function. So I agree that it looks like these guys are going to become straight up and down, but they won't ever come straight up and down. They're going to keep going out just a little bit as they go down. So it's also a function. So now for the ones that are functions, we're going to come back in, find their domain and range, and then we're going to find their intercepts and also talk about the symmetry. So because I need the room, I'm going to erase the ones that are not functions. So B, we're going to write over here. So again, domain is left side to right side. Now, because of this arrow, this is going down as it's going out. And this arrow, it tells me it's going down as it's going out. So if I'm going to look from left to right, we're going to go from negative infinity to infinity. So left to right. The left side is out there at negative infinity in terms of x. The right side is a positive in terms of x. What about the range, though? Well, the range is a little bit different. It's the bottom of the graph. These arrows are telling me it's headed down towards infinity. So it's going at negative infinity. But it stops. The top of the graph is up here at a y value of 2. We're going to use a bracket because there's closed circles there, and that's included in part of the graph. The x-intercepts are pretty easy. They're over here at -3 and +3. And the y-intercept is up there at 2. Now, what about symmetry? So, symmetry. Can you fold this anywhere? Well, sure enough, if I use my y-axis and fold this, doesn't it fold across the y-axis? It folds onto itself. So it has symmetry to the y-axis. Not the x-axis, because if I fold top to bottom, it won't fold to itself. Because there's no x-axis going on here when we try and fold it onto itself across the origin. That's that double fold. It won't work. So the only symmetry it has is to the y-axis. Yay! Okay, and for part C, I'm going to erase this one. So I can write part C, the answers on the board. So for part C, what about its domain and range? So this one's kind of goofy. So as this goes down, we're going to assume that it's getting closer and closer to the axis, but never actually touches that axis. So we're going to say the domain starts over there at 0 because it's not touching the axis. We'll use an open, a parenthesis. It's going to stop at the x value of 3. And I think I have that plotted right. That's 3, 2. Yeah, 3, 2. So from 0 to 3, because it's an open circle, we'll put a parenthesis there. Okay, the range is the bottom of the graph. The bottom of the graph is this arrow. It's down there at negative infinity. The top of the graph is up there at 2. So again, left to right, bottom to top, left to right, bottom to top. Okay, x-intercept, it definitely has one. Its x-intercept is at 1, 0. It doesn't have a y-intercept because we said it doesn't touch that y-axis. So we're going to say none. And then in terms of symmetry, it doesn't have any folding that we can do. If we fold it left to right, it puts it over here. If we fold it top to bottom, it doesn't fold to itself. If double folding doesn't work either. So symmetry is none. What about part D? So part D, domain. So the left side of this graph is over here at -pi. The right side of the graph is at pi. So our domain is going to go from -pi to pi because they're included on the picture. They are closed dots. We know that those are closed brackets or brackets. The range is the bottom of the graph, which is over here at -1. The top of the graph is at +1. So we're going to go from -1 to 1. Left to right for domain, bottom to top for range. the x-intercepts are at pi over 2. So negative pi over 2, comma 0, and positive pi over 2, comma 0. What about the y-intercept? Well, it has one. The y-intercept is the positive 1, so 0, 1. It does have some symmetry. We fold from left to right. We're going to see that it folds itself onto itself. So it has symmetry to the y-axis again. Yay! Okay, and then finally, F. Again, those arrows down here are saying it's going down and out, down and out. So our domain is going to go from negative infinity to infinity. Every x value is going to get used. What about the range, though? Because this has a top, and this top is up here at 5. So that I think was 1/2, 5. So the range is going to go from negative infinity to positive 5 with a bracket because it is included on that picture. We do have x-intercepts. It's crossing the x-axis at negative 1 and at positive 2. It's also crossing the y-axis. My picture may not be as good, so the y-intercept, sorry, it's getting really sloppy. It's hard to write the bottom of the word. Is up there at 4. And it has no symmetry to the axes or the origin. Now, it has its own type of symmetry, and when we graph quadratics in chapter 4, we'll talk about that symmetry. There's a line of symmetry right through the middle of it, but in terms of an axis, it's not going to fold onto itself across either the axes or the origin. So there are 6 pictures total. 4 were functions. We found the information for those that were functions. We did not have to find the information for those that were not functions.